Hello, I'm Garth Skews from Group 3 Electrical Engineering Company, and I'm excited to announce our partnership with the Discovery Channel in supplying a sustainable power supply solution to South Australia's Maple Creek. I will be outlining the context and location of Maple Creek, the project scope and boundaries, the main deliverables, acceptance criteria, and constraints. Maple Creek is a station located 45 kilometres west of Coober Pedy in the northern region of South Australia. The station is approximately 4,500 square kilometres. It is grazing property, owned by the Antacarinja Matu Yankunytjara Aboriginal Corporation, AMYAC, which is currently leased to a group, Saltbush Ag, providing training and employment to local Indigenous people. Like Coober Pedy, the geology and terrain is perfect for the fosking of opal. As for the project scope, we are to design, supply and install infrastructure to generate and distribute 250 kilowatts of three-phase 415-volt power to 12 domestic dwellings, as well as a general store and a mains water pumping station. The pumps and pipework will be supplied by an external contractor. Due to factors that will be outlined later in the presentation, Group 3 Engineering has decided that a solar farm with backup diesel generator is the best option for quality of supply. Our responsibilities begin with surveying an appropriate location for the generation site to be located. Once this is complete, the site will then be secured to restrict any access from livestock or native fauna. We will deliver solar panels to adequately provide 250 kilowatts of power, including support and protective infrastructure. We will deliver a standby diesel generator with automatic changeover function, as well as a step-down transformer. This installation also includes all associated wirings to dwellings, as well as protection systems. For this project to be a success, we'll be in direct consultation with the traditional landowners represented by AMYAC. All works will be in accordance with the SA Environmental Protection Act. All works shall be completed to the Australian Standard for Electrical Installations, AS-NZ 3000, as well as the Standard for Battery Energy Storage System Installation Requirements, AS-NZS 5139, as well as AS-NZS 2067, the Standard for High Voltage and Substation Installations. As the Discovery Channel have prioritised this production, there is no fixed budget. However, the entire project must be completed in 6 months from August 2025. The delivery of power to Maple Creek must be as environmentally sustainable as possible to ensure minimal impact to the native flora and fauna in the area. Due to the remote location of Maple Creek, the installation will need to be able to withstand harsh weather conditions and be able to perform efficiently enough with a low maintenance schedule.
Hello, my name is Aaron Lloyd. I'm doing the requirements analysis section of this project. I'll be talking about the inputs, outputs, functions, environmental issues, packaging issues, safety issues, and some maintenance issues. And to start out, we'll talk about the inputs. So the inputs for the system, we're talking off-grid, isolated generation and distribution. So we're generating and distributing, and the system's got to be able to take inputs from AC and DC sources, e.g. a generator that generates AC, or say solar that generates DC, and it's got to be compatible with renewable and non-renewable sources like fossil fuels and say wind or solar. In terms of outputs, it's got to be able to output alternating current, single phase and three phase, 240 volt and 415. It's got to be at 50 hertz and maintain 50 hertz and meet the maximum demand of the camp. So some required functions of this system. We're talking about the generation of AC and DC, potentially inverters from DC to AC, the distribution of AC 240 volt and 415, provide reliable and stable power quality, and it also require a smooth transition from sources from solar to diesel generation and the changeover, so no outages or minimal at least, and we need fault protection through protection systems for the system. Now for environmental issues, so we're talking about temperature and humidity at Maple Creek, which is our location, so the equipment may need to be indoors to maintain safe operating temperatures and control humidity. Also some dust filtration to keep the rooms clean, and maybe the solar panels will also need to be cleaned. A generator may need noise suppression when it's operational, and we'll also need pest and vermin protection for the system and plant. Okay, packaging issues. So the compatible equipment and housings like switchboards, inverters, plant across the generation distribution system all needs to be compatible and work fluidly. Equipment to be installed with maintenance and possible replacements in mind. So clearances of ease of access. So we need to replace inverters, breakers, generators, solar panels, just easily accessible to do so. Cable management systems for all the cables and security and protection of those cables. Also need labels to clearly identify the plant and equipment, any danger labels maybe. And it's all constructed to comply with industry standards and building codes as well. There's some safety issues we need to address. So equipment and assets of the system to be secured in a manner to protect people, plant and continuity of supply. So maybe there's a fenced off substation and whatnot. Maintaining clearances from live equipment of safe approach limits and the use of isolation barriers. So obviously everything's away and safe, people can't touch it, or there's a physical barrier where we cannot touch anything dangerous. Protection systems required for monitoring, fault detection and isolation, so the system can be monitored and controlled remotely for any outages or faults that need to be controlled, and appropriate systems in place of fires, equipment fighting chemical spills like fire prevention systems, spill kits for any dangerous chemicals or fuel like for what we may need for a generator. Now, some maintenance issues of a project. System will require regular inspections, maintenance, testing cycles. Like all equipment, you've got to keep it maintained. Testing and maintenance of plant protection and systems. So obviously the plant needs to be tested and maintained. The protection systems need to always be working with no faults in those systems in case there is a fault. And a site may require regular foliage and vermin controls, just keeping no weeds out, no growing trees, and obviously no pests in there to destroy any of your equipment. And maintenance and testing of secondary systems like fire suppression, air conditioners, alarms, keeping our equipment obviously safe from any fires, maintaining its temperatures and humidity, and alarms, if they need to be activated, need to obviously work. That's the end of requirements analysis. Thank you for listening.
Hello, my name is Kim and I will be running through the analysis of alternative solutions for the provision of power to the new Mabel Creek site. I will be outlining the definitions of the chosen power solutions and the grid and SWOT analysis used for comparison of those solutions. In this slide, we introduce 4 power supply options considered for the Mabel Creek location. Solar power generates electricity from sunlight using panels. Wind turbines convert wind into electricity. Overhead line distribution brings in grid power through poles and cabling. And diesel generation involves burning of diesel fuel in a generator to create power on site. Each of these have unique characteristics and they will be explored in further slides. This grid analysis compares the 4 options across 4 factors: cost, environmental impact, reliability, and maintenance. As you can see, solar has low environmental impact and operating costs, but relies on sunlight. Wind turbines need wind and regular maintenance. Overhead line distribution is reliable, but very costly and disruptive to the environment. Diesel generators are highly reliable, but involve high fuel and environmental costs. Each option has its own strengths and challenges. Solar is clean and low maintenance, but depends on sunlight. Wind is renewable, but inconsistent. Overhead lines are reliable if the grid is nearby, but expensive and invasive. Diesel offers dependable power, but with major environmental and fuel costs. These swap points help determine which options align best with the site and conditions.
The following risks were identified for the project. Technical risks. battery failure due to extreme temperatures, solar panel underperformance due to shading and dust, inverter malfunction. Some mitigation strategies to be put in place. The procurement of high-end batteries and inverters rated for high temperature environments. Program maintenance for the cleaning of panels. No shading issues due to the lack of trees in the vicinity. Ensure spare inverters are readily available and on site. Financial risks. Following risks were identified due to transport logistics, technical risks, fluctuation failure due to extreme temperatures, delays in funding components due to shading and dust, mitigation strategies, inverter malfunction, lock-in rates with the logistics provider, some mitigation strategies, negotiate fixed price contracts with suppliers, procurement of high-end batteries and inverters, arrange bridging rated for high temperature environments, program maintenance, social risks for the cleaning of panels, vandalism, no shading issues due to the lack of trees in the vicinity, mitigation strategy, ensure spare inverters, ensure generation available and adequately fenced and protected.
Detailed specifications for solar generation, battery storage, and distribution components. We have our PV solar panels, which are corrosion resistant, connected to our lithium batteries, which are fast charging, require minimal maintenance, and are cost effective, which will be connected to our DC combiner box, which consists of surge protection, converted to our string inverters, which have few connections and are cost effective, and our load is split into 3 sections, including the pump and the general store. And with all this, it's coupled to a generator which has an auto changeover switch with a no volt sensor.
Inverter malfunction. Some mitigation strategies to be put in place.
This slide presents the work breakdown structure for the solar project. Developed under Electrical Engineering Company, it outlines 6 major phases of work, from project initiation to project closure. Each level is broken down into clear work packages, such as site visits, stakeholder consultations, system design, installation activities, and final client handover. The work breakdown structure ensures that all tasks are identified, structured, and easy to manage for scheduling and resource allocation purposes.
Procurement of high-end batteries and inverters rated for high
Here
temperature
we have a Gantt
environments.
chart
Program
representing the
maintenance
full project
for cleaning of
timeline,
panels.
starting in August
No shading issues
2025
due to the lack
and
of trees
concluding
in
in
the
early
vicinity.
February
Ensure
2026.
spare inverters are
The
readily
visual
available
schedule
and
maps out
on-site.
each task from the work breakdown structure against time.
The following
Dependencies
risks were
between
identified
tasks
for
are
the
shown with
project.
linked arrows, providing a
Technical
clear
risks.
view of
Battery
task
failure due to
sequencing
extreme
and
temperatures.
durations.
Solar panel
Color-coded
underperformance
bars
due to shading
represent
and
each
dust.
phase of the project,
Inverter
making it
malfunction.
easy to track progress
Some
and
mitigation
identify
strategies to be put in
critical
place.
path items.
Procurement of high-end batteries and inverters rated for
Here
high
we see the
temperature
network
environments.
diagram, which
Program
outlines the
maintenance
logical
for the cleaning of
flow
panels.
and dependencies
No
of
shading
each
issues
key
due to the lack
activity.
of trees in the
The
vicinity.
project begins on
Ensure
August
spare
1st,
inverters are readily
2025,
available
with
and
parallel
on-site.
tasks such as the site visit and stakeholder consultation feeding into
Following
the
risks were
system
identified for the
specification.
project. Technical risks.
The sequence
Battery
continues
failure due to extreme
through
temperatures.
planning, equipment
Solar
sourcing,
panel
installation,
underperformance due to shading
and
dust.
testing,
Inverter
finally
malfunction.
concluding with final handover
Some
and project
mitigation
completion
strategies to be put
within
in
6
place.
months, ending
Procurement
February
of high-end
2nd,
batteries and inverters
2026.
rated for high
This
temperature environments.
diagram is a valuable
Program
tool for
maintenance
identifying the
cleaning of
critical
panels.
path and
No
ensuring
shading issues
efficient
due to the lack of
coordination
trees in the vicinity.
across all project
Ensure
stages.
spare inverters are readily available and on site.
This concludes Group 3 Electrical Engineering Project.
Following risks were
The
identified for
project
the
delivered a
project.
practical and sustainable
risks.
solution to supply
Battery failure
reliable
due to extreme
electricity
temperatures.
to the remote Mabel
Solar
Creek
panel
community.
underperformance due to shading
Through a
and dust.
structured approach,
Inverter
beginning with a
malfunction.
detailed analysis, system planning,
Some
and careful
mitigation
risk
strategies to be
mitigation,
put in place.
we've created a
Procurement of
design
high-end batteries and
that is
inverters
resilient,
rated for
low
high
maintenance,
temperature
and
environments.
environmentally
Program
conscious.
maintenance
The
for
project
cleaning of
reflects
panels.
our team's
No shading issues due
commitment
to the lack
to
of
both
trees in the
technical
vicinity.
excellence and meaningful
Ensure
impact.
spare inverters are
Thank
readily
you.
available and on site.